Alright guys, so today, I know I haven't posted a video in a long time. I just haven't had time between school and work, and also I didn't know what to do. Like what kind of projects to do. So today, we are going to go over the IT'd Studio motor shield board for the Arduino. So you'll need the motor shield and the Arduino. I have the Arduino Uno R3. And then what I'm going to do with it is I got an old RC car from my cousin, and I'm taking the board off of it, and then I'm going to hook the two motors up to the motor shield, and then it's got the battery compartment on the bottom, and then we're going to make that an autonomous vehicle. But first, let's get the understanding of this down, how it works, and control two separate motors with this board before we get into making this autonomous. So let's get started. So to start off with, let's take a closer look at the motor shield. This is the box came in. It's actually Seed Studio, not IT. I was thinking of my touchscreen shield I have for this. On the back it tells you your features. It supports up to 14 servos, which that is all your white connectors here are for your servos. On the back it says it has a 5-volt regulator, so it'll power the Arduino, and you don't need a separate power supply. And then it takes in 6 to 15 volts. So you'll put 6 to 15 volts in this left one, and in the right one you put your ground. Then the white connectors are all your servos, and then these 4 connections here are for 2 more standard motors. So you have M1 positive, M1 negative, M2 negative, M2 positive. So we're actually going to be using these 4 connectors today, and they're screw connectors. So let's go from there. So first we're going to take our Arduino, and then we're going to put our motor shield onto it. Just sits on right like that, pushes down. It goes on nicer than the touchscreen. You don't really have as much, I'm not even on the camera. Right here you don't have as much gap, and the gap at all is so tiny you can't even really see it. So it goes on a lot nicer because we don't have, I think on the touchscreen the SD socket is right here, and that's why it doesn't go on, but I can't remember exactly if that's where it's at. So then the 2 motors we're going to be using today, or at least I'm using, are these 2. It's just 2 random motors I got out of, I don't even remember what I got them out of, but these are what we're going to hook up today. So I will get them hooked up, and then I will resume the video from there. So real quick, this is how we have it hooked up. This is our positive and negative for the power supply, which yeah, that's right. That's positive and negative for your power supply. It tells you right in front of it, but they're covered up what's ground. You can kind of see it back in there. It tells you ground, and then VCC, I believe. VS is what that's called. And then you got your motor. I think this is motor 1. This left side, the black and white, is our motor 2, and the red and white are our motor 1, I believe. Yeah. And it tells you positive and negative down there, but I don't have enough resolution on this camera to see it. And then that's just hooked up to our two motors. And now let's go get to programming and then we'll see how it works. Okay, so here, this sets up our motor 1. This is going to be the same thing every time. It will never change unless you're using different motors. But for the motors we're using and the sockets we're using, this is what it's going to be for motor 1, and this is going to be what we use for motor 2. It's going to be pin I3, pin I4. You can call them that. It doesn't matter what you call them. It's going to be 12, 13, and speed. It's going to be on pin 10. That's what we'll send our speed value to, how fast we want the motor to turn. Same with this. It's 8, 11, and 9 for motor 1. Motor 2 is 12, 13, and 10. Now this is just a variable to set our speed. We don't need that. You could do it, just come down here and put in the values here of what you wanted them to, what the speed to be. But I just did it that way. That way it's easier to change. I only have to change one number if I want to change the speed compared to having to change multiple numbers. So then we have our setup function. That's just setting all the pins to outputs. That's pretty simple. And then we come down to our main loop. If you're doing like a robot, you could do like forwards, backwards, and all that, and make different functions for them and just call them in here. The thing is, we're just spinning them. I really have no purpose to make other loops. I'll do that whenever I do the other. Actually turn the RC car into something. So this is just writing to the board as to what pin we want to send it to and how fast we want to spin it, like what the speed to be, which we defined here. So you do that for motor 1 and motor 2, so they're going to be spinning at the same speed. And this turns motor 1 counterclockwise. So if what I called pin I2, so if pin 11 you set low, you got to set the other one high, and that'll spin it counterclockwise. But if you see for motor 2, I did it the opposite way, so this will be counterclockwise. So that, if we change this to high and this to low, that would be clockwise. This low to this high would be counterclockwise. So that's all the code that we need to actually turn the motor. So let's get the code put on and let's see what it does. So it's all hooked up, wired up, and programmed. So it's time to plug it in and see what happens. But one note real quick before we start. Power. Don't run it off your USB port. You don't have enough voltage there. I believe at most it outputs 5 volts. Correct me if I'm wrong. So I'm using a old desktop power supply. I have it plugged into the 11.8 volts that way. I wouldn't recommend doing it that way. That's probably not the safest way to do it. So motors are hooked up, power supply is hooked up. Let's plug it in and see what happens. The motor should be spinning at full speed. You can see that one take off. I don't know if you can see it spinning there. You can hear it. And this one is spinning as well. It's supposed to be a geared. You can hear that one too. So I'm going to unplug it because that's really loud and annoying. There, you seen it stop. It twitched back from when it stopped. That's what it looks like not running, and that's what this one looks like not running. Now you can play with your values for your speed and your direction pins, changing them high to low. But this is pretty much the basics of how the motor shield works and what the code looks like whenever you have to write it to put it on it. I don't have any motors that have these connections. I just have I have servos, but the connectors are different. I believe this supports, yeah, it's compatible. I don't know if you can read it. Compatible with groove, plug, and play sensors, and I do not have any of those, at least not yet. If you guys are interested, let me know. I can try to find some and I'll make videos about that. But if you guys aren't interested, I'm not gonna waste the time and money to go get some of those sensors. So if you like this video, please subscribe and like, and comment below with other videos that you would like to see done, and I'll try to get those done as soon as I can.